Hello everyone, I'm Rahul Shandilya, and in this new lecture of Internet Things, we'll discuss IoT use cases for uh, energy, smart energy management. So, energy is the most important resources. The source of energy are the most important resources for human being because without them, nothing in modern life, in fact, in early life also, nothing is possible. Uh, the energy resource can be natural, for example, in early our civilization we used woods, dry woods as a source of energy mainly. But nowadays the human demand is huge and mostly it is produced from the industry using coal, burning coals, using nuclear power, using thermal power, using hydraulic power, and now we have another renewables, new kind of resources like renewable resources like wind, especially solar efficiency as an energy resource again uh, much in recent year, and now it is deployed in a larger scale. So how can IoT helps in managing energy, maintaining, making this energy management as smart, which is very important because uh, the there are different kind, as I told, there are now different kind of energy resources. So no particular way can be deployed suits in every type. So mostly in every type of energy resource we need informations so that it can be controlled and monitored continuously. And IoT can help in providing these information in real time so that we can avoid failure, we can detect the necessity, detect the demand on time. Also, distribute it can help to distribute properly, that is load balancing. So let's cover the IoT importance of IoT in maintaining and in energy. Energy. The first one is a smart grid. What is grid? A smart grid is a data communication network. Uh, Basically, a grid is a network where the energy uh, from the resources is connected with the consumers. So, for example, we have energy resources from various uh, production sites like thermal, or from that is connected to some smart grid, and from that grid is connected to the directly to the consumer's level. So a grid is a very important place because from that only we basically do the balance between the demand and uh, production, demand and supply of the power. This is very important. Smart grid is a data communication network integrated with electrical grid that collects and analyzes data captured in near real time about the power transmission, distribution, and consumption. So, making it smart means uh, collecting the data in real time uh, about the transmission, distribution, and consumption. So, a smart grid technology provides prediction information and recommendation to utilities, their suppliers, and their customers on how best to manage power. Smart grid collects data regarding electricity generation, centralized or distributed, consumption, instantaneous or predictive, storage or conversion of energy into other forms, distributions, and equipment health data. Smart grids use high-speed, fully integrated two-way communication technology for real-time information and power exchange. By analyzing the data on power generation, transmission, and consumption, a smart grid can improve efficiency throughout the electric system. So basically, the most important thing is a smart grid collect data regarding electricity generation. So how it checks the supply level. consumption, check the demand level. And then storage, it can help storage for in the energy. And the most important, also one of the most important thing is it can say monitor the equipment health. Cloud-based monitoring of smart grid data can improve energy usage level via energy feedback to users, coupled with real-time pricing information. So, pricing information can be done using a smart grid in real time, just like say the cloud server. The cloud provided services in real time means we can have nowadays the CPU demands, RAM demands, bandwidth demands per second by charging it in a second. So means uh, that can also helps in we can make a smart grid like that. A real-time demand response and management strategy can be used for lowering peak demands and overall load via appliance control and energy storage mechanism. So the one of the important advantage is for charging real times is that using that we can say for example do the load balancings and control properly. For example, when there is this supply in plenty, we can lower the prices so that um, in real time, so that people start consuming it more. And when we have shortage, we can increase the power prices in real time so that people can stop using the energy more. So this is a very important say in it can help in in balancing the load. Conditional monitoring data collected from the power generation and transmission system can help in detecting faults and predicting outages. Another important is smart meter. A smart meter is related to also is helps in making that kind of service possible. That is real time, say charging, because for that a smart meter should be also possible. Users should know how what is the charging rate in a real time, means in a particular time, in particular instances, and it can say mm, alarm the people by some sound, by beep, or say the fan rate will get changes, or it can display in the current rate of charging of electricity using various techniques. So a smart meter is very important. It can to avoid the theft electricity to proper charging. Renewable energy management system, energy system. Renewable energy, as I told, nowadays solar energy. Basically, the solar energy is deployed in large scales as a source of energy, and it is a distributed source. So the its management is different from say the thermal or hydraulic energy. Due to variability in the output from renewable energy sources such as solar and wind, integrating them into the grid can cause grid stability and reliability problems. Because its output varies from, for example, solar outputs uh, from in a day is very different from solar outputs in night. It's basically at night it stop working. So or even if they are storing and somehow still there is a significant uh, difference in the supply magnitude at the night or day. So these variable outputs produce local can cause a problem for the grid to maintain stability and reliability. So various output produces local voltage swings that can impact power quality. Existing grids were designed to handle power flow from centralized generation resource to the loads through transmissions and distribution lines. When distributed renewable energy resources are integrated into the grids, they create power bidirectional power flow for which the grids were not originally designed. IoT-based systems integrated with the transformer at the point of interconnection measure the electrical variables and how much power is fed into the grid. To ensure the grid stability, one solution is to simply cut off the power production. For wind energy system, closed-loop controls can be used to regulate the voltage at the point of interconnections which coordinate wind turbine outputs and provide reactive power supports. Next important is the prognostics. Basically, energy systems have a large number of critical components that must function correctly so that the system can perform their operation correctly. These systems must be monitored carefully as wear and tear in such critical components or sudden changes in the operation condition of the machine can result in failure. So, continuous supply of energy is important, and to make sure that it is not disruptive, it is not uh, we have to ensure that equipments work continuously. We have to ensure that we can check, means we can predict its failure, so that before it is disrupted totally we can replace that important equipment. So how it is possible? By measuring the health of the important equipment in real time using some sensors on using IoT infrastructures. In systems such as power grid, real-time information is collected using a specialized electric sensor called phasor measurement units. PMU at the substation. The information received from PMU must be monitored in real time for estimating the state of the system and for predicting failures. Energy systems have thousands of sensors that gather real-time maintenance data continuously for condition monitoring and failure prediction purposes. IoT-based prognostic real-time health management system can predict performance of machine or energy system by analyzing the extent of degradation of system from its normal operating profiles. Analyzing massive amounts of maintenance data collected from sensors in energy system and equipment can provide predictions for impending failures potentially in real time so that their reliability and availability can be improved. Prognostic health management systems have been developed for different energy systems. So this is the applications of IoT in way managing our energy, making it our more smart and reliable to increase the efficiency. And in next lecture we will discuss IoT application retail and logistics. Again, very important part of our life, industries.